right, page 182. Let's take a look at your homework. You did numbers 1, 5, and 8 last night. If you would go and hold the homework up so that I can see that you constructed a square, a rhombus, and a parallelogram. All right. Square, rhombus, and sort of a parallelogram there. All right. Oh my.
I don't really know what that is.
Oh my. Okay. All right. Good. And do not have that. All right, let's go and start with number 1. And we were constructing a square, obviously. What were we given about our square? Genesis?
Number 1. Okay, constructed square having given the sum of the 4 sides.
Good, we're given the sum of the 4 sides. And how many of you thought, hey, I know what to do here. We had the sum of the sides of an equilateral triangle. I'm on to these ways now. So, yeah, hopefully you had a line, right? And it was hopefully a very long line. You know, maybe 4 or 5 inches long. Oh. Yeah. Hopefully you called it A plus B plus C plus D. All right, that feels right there. Or something, I don't know what that was. All right, so anyway, so we're constructing a square given the sum of the 4 sides. Now, I believe all of you went and drew a long line underneath, right? Marked off 4 equal pieces, scribbled off the excess maybe, connected up the end, made an arc, and made parallels, parallel, to divide into 4 pieces. Then you would have taken another line to be your baseline, right? And you would have probably picked a point not on the end, right? So you construct a perpendicular. You'd mark off a distance, construct another perpendicular, mark that distance off, and connect across the top. How many of you that's exactly what you did? All right, that's not what I'm going to do because I'm lazy. Oh. And there's a better way. Because, you see, it's 4 equal pieces we need, right?
Yes.
4. That's a multiple of 2. Which means I could, instead of doing the long line thing, I could do a perpendicular bisector to break it into 2 parts, right? And then I could perpendicularly bisect either, not both, because I'm lazy, of these halves, right? To get another 4th. And the question might be, well, Mr. Dusky, how is this any better than my way of dividing it with the parallels? Does anyone see the advantage in doing it this way? Well, not that much faster, maybe a little, but the real advantage is, anyone?
Right, you already have right angles.
I already have my right angles. My perpendiculars are already on the picture. I just measure this little piece. Oh.
That's exactly what I did.
And when I connect it across the top,
That's what I was doing.
I've got it. And there's my square. All right, now, not that the other way's wrong by any stretch, but the overthinking lazy mathematicians like, because it's 4, I use perpendicular bisectors and do it that way. But the other way is not wrong by any stretch, okay? So I think, Ethan, you said you did do it this way. Anyone else do it this way?
That's what I was doing.
That's what you was doing, okay?
But
all right. Questions at all on this construction? Any questions at all? All right, let's go on to the next one, number 5. And we were constructing a rhombus this time. And what were we given about our rhombus? Quentin?
Construct a rhombus having given the 2 diagonals.
The 2 diagonals, you said?
Yes.
Now, question, are the diagonals of a rhombus equal? No, not necessarily. If they are, you've got a square instead of a rhombus, which is still a rhombus, I suppose. But yeah, when you draw your diagonals, you should have drawn a longer diagonal and a shorter diagonal. And we could call these, they don't have to be one a lot longer than the other, but I'm going to call them D1 and D2 for my 2 diagonals. And, well, let's think about the rhombus, specifically about the diagonals. What do we know about the diagonals of a rhombus, Chris?
They bisect.
They do bisect each other. That's important to remember. What else do we know about the
Guess
diagonals?
not the angles.
They will bisect the angles of the rhombus.
They're
That's
perpendicular?
correct. They'll be perpendicular to each other. The only thing that won't be is equal, right? So, as I draw my sketch, I draw my best attempt at a rhombus, which is really lousy, but that's okay, because it's just a sketch. Here's my long diagonal. That's got to be D1. Here's my shorter diagonal. This one's got to be D2. But I've got half of D1 here, half of D1 here, half of D2 here, half of D2 here, and they are perpendicular to each other. Therefore, they are perpendicular bisectors. Now, that's all I know. I don't know anything about these lines. So when I go to draw my big long line, which I didn't have to do last time, but doing it my way, right? You could have, and I mentioned how we would have done that. If I want to make my starting point down here, I'm going to go ahead and draw my line at an angle like this, and put my starting point down here. What should I do now, Jamie?
Measure one of the diagonals.
Oh, not one of them. Specifically, measure
the long one?
the long one, right? The way I've got my picture drawn, if I'm going to follow the sketch, I need the first one. Now, technically, Jamie, you could do the other one. Which it would just shift the other way and slant backwards, which is not wrong. But yeah, if we're going to want to follow the blueprint, which is what I strongly encourage, start with the first diagonal. And in marking this point off, I now know 2 of my 4 vertices. What do you suppose we would do next, Genesis?
Measure the second diagonal.
I'm not quite ready for that yet. Kendall?
Do the perpendicular bisector.
Good. I know where the second diagonal is going to go, Genesis, right? It's going to go right along here. But I'm not ready to measure it because I don't have that there yet. So let's do a perpendicular bisector next. And again, when I talk about key points, the vertices are the most key points. But major points of intersection can function as key points on the sketch as well. And in getting this perpendicular bisector, I do have now another key point of my sketch. Let's see, let's go, now Genesis, you had said measure the second diagonal, right? If I measure the second diagonal, what do I do with this diagonal length? Like, how do I know where to put it? Well, if I do, then I'd be putting the entire diagonal down below here, right? And I don't want the whole diagonal, I only want half of it above and half of it below. So I don't even actually want this diagonal measurement. I really want, how would I get half of this? Do another perpendicular bisector on this diagonal right here, and if we'll perpendicularly bisect said diagonal, I can measure not the whole diagonal, but half of it, and put half of it on one side, and half of it on the other. There's half of D2, there's the other half of D2. I've now found all 4 points, vertices I should say, of my rhombus. And when I connect the dots, I've got the rhombus completed. And how many essentially did this for your construction? Hold up your hand, leave it up till I have a chance to see it. All right, 3 of you, okay. Questions from those who didn't get it?
I thought the diagonals were equal.
Okay, so you ended up with a square then, right?
Basically.
Okay.
I take full blame for that. I told him that they were equal.
Well, it's his fault for listening to you. He should know better.
Yeah, actually. Very true.
All right, Quentin, Genesis, questions? Get it now? All right. And let's take a look at our last one, which I think was a parallelogram on number 8. What were we given on number 8? Audrey? At first, I just heard that noise. I was like, man, her voice got low. No, It's an airplane. Unfortunately, it made me totally distracted. Parallelogram and what? Given one side and two diagonals. Now again, for a parallelogram, the diagonals are not necessarily equal, okay? If you drew them as equal, you've got a rectangle. So I'm going to actually start with the sketch here. Most of the time, when we have a parallelogram, we have long top and bottom and short upward sides, right? It's not wrong if you did short and longer here, but normally this is how we do it. Audrey, you can give yourself any side you want. Top, bottom, left, or right. Which side do you want to give yourself? I love giving myself the baseline. Okay, huge fan of baseline. So I'm going to say that this baseline is the one side that I'm given, okay? Because it could be any side. I could always rotate it if it weren't, right? Or flip it if it were the top. So I'm going to give myself a rather long side to be the base. Now, I've got two diagonals. One of them is short, one of them is long. But I got to ask you, Audrey, how does this length compare to this length? The short diagonal compared to the base. How do they compare? Anyone?
They're equal.
They're about the same. They're not necessarily exactly equal, but they look really close to equal, right? So when we draw our line for our short diagonal, make it pretty much the same length. Maybe a little shorter, maybe a little longer. I'm going to go just a little bit shorter and call this the D sub S, diagonal short. Okay? Now this one's really easy for you, Audrey. How does the longer diagonal compare to the base? Longer. Okay, good. So as long as we made one of our diagonals, I don't know, maybe even considerably longer, maybe a fair bit longer. I'm going to do D sub L for diagonal long. We had to have a line definitely longer than our side, and another line that could have been maybe still longer, maybe about the same, maybe a little shorter, somewhere in that neighborhood. This is kind of mental planning here, but we're given D sub L and D sub S. All right? Question?
In a parallelogram, so the diagonals are not equal.
Only in a rectangle.
But they bisect each other.
They do still bisect each other. That's a good point. So right here is the midpoint of the diagonal. So here's half of D sub S, and here's half of D sub L, right?
We don't want D sub S.
I'm sorry?
Well, we don't want D sub S because we're going to do the same thing as the rhombus, aren't we? We're going to have to use half of it.
Okay, you're getting a little bit ahead of me here, but yeah, we're going to end up needing halves then. Do we get the idea? Halves are going to come in handy here. All right, but that said, let's pick a starting point for our construction.
If we have one side in a parallelogram, isn't the other side equal to it?
This top side will be, yes. We know that this side and this side will both be the same
Is
length.
that going to help us?
It could. It certainly could. Let's go and get started. We want a big long line. Now here's the question. Do you want to make the big long line this diagonal, or this side? I'd make it the base, right? Given the choice, since there is a baseline, I put the big long line down here, and I'm just going to make this first point right here. Again, I'm not putting a perpendicular there is the key. If I want a perpendicular at that point, I need to give myself room to make it, but I don't need a perpendicular. And so the first, probably most obvious thing, class, would be to measure the base, right? And Mark, can I reach this far, by the way? Oh, barely. Okay. That is the other thing. You don't want to draw a line so long your compass can't reach. And I almost did. So we measure the base, and we mark it off. And so now I know 2 of the vertices of my parallelogram. All right, what might we do next? Chris?
Maybe measure out the what are they called? Diagonals?
Okay, so let's go and take that long diagonal. And here's the only problem, if I can get it to give me the measurement, is if I measure the long diagonal, I know the long diagonal is going to attach down here, right? But I don't know where the other end goes. I just know locus here, if I get the chalk to actually go up, it's somewhere along that line out there. Does that make sense? But I don't know where. I could do the same thing with the short diagonal, I suppose, and I could say, well, I know the short diagonal is going to start here, and it's going to go somewhere out there.
Wait, the point where the two lines intersect, is that anything?
You talking about where these two arcs intersect, or are you talking about where the diagonals will intersect?
The arcs.
Where the arcs intersect?
That's not anything?
Well,
because I don't remember anything about that, but...
I don't think it's going to give us anything of significance, to be quite frank. I don't think that's going to be the point of that point out there that we want. Huh. So, measuring the diagonals and like kind of just making big arcs, locus arcs, isn't seeming to work too well.
Parallel, but I don't know if that's going to do anything.
Well, I know there's going to be some line coming up here, but I don't know at what angle to make it, right? So that's no help. Anyone? Suggestions? Looking at our sketch, any suggestions based on our sketch? Halves are in there, right? You see, this diagonal's end and this diagonal's end aren't ever supposed to meet, are they? But this diagonal's half and this diagonal's half are supposed to meet, right? So instead of worrying about the entire diagonals, let's get halves and find the point where they're going to intersect. Does that make sense? So what does that mean I'm going to have to do with each of these, class? Perpendicular bisector. Now the hard part is they're stacked on top of each other. So when I draw the perpendicular bisector D sub S, the short diagonal, my suggestion is don't draw it going through the long diagonal. So I've got the line lined up here. Okay, and so I've got my half, but I didn't actually make any markings here that could confuse me. Now I can also bisect the longer diagonal. And that's really the key to completing this, is again, not locating the vertex, but that point of intersection where the diagonals come together. And again, I'm not going to draw this going through both of them. So now that we've got our halves, how do I make that come together? Jamie?
Would you make arcs like we just were, but now they'll intersect?
Right. These arcs never had any business intersecting, or even if they did, it doesn't matter. But if I can make arcs with the halves, they better intersect, and it does matter. So now if I start by the half D sub S, Jamie, where do I put the point of my compass?
On the right.
Good. You need a compass. Look, short diagonal's coming here. You better put it here for your short diagonal. All right? So there's that short diagonal arc. And then for the long diagonal arc, class, obviously we're going to put that on the left point. And where they intersect has to be that middle point of intersection. By the way, since I went ahead and made that whole arc out there, I can go right through this point now and go all the way to that arc. So it's not even necessarily that I wasted my time making it, right? If I'd made the half, I'd have to measure another half. Well, it's already out there. Same thing here. I go through this point of intersection, but I'm going to go all the way out. Oh, I think that's going to miss.
So what I did wasn't a complete waste of time?
It was not.
Huh.
Yes!
No more auxiliary lines.
So this point and this point, there's my middle point of intersection, must be the other points of the parallelogram, and if I'll just connect them down, I feel like I'm just a nudge off here with my chalk, I'll get the parallelogram with this side and those two diagonals.
Would it have been easier if you did one of the diagonals as a big long line?
Well, the only thing is, you would still have to find this midpoint, right? And when you do, it's not the you're going to use a perpendicular bisector to get it, but the line itself is worthless. You'd still have to know where to put this line. There's a lot of different angles you could have put it at. And then, what I would have done is measure the half diagonal S, make an arc. go up to this end and measure the baseline, make an arc, and where they intersect is my point. So you could have started on the diagonal line, but I think this is more intuitive, to be quite honest. But it could have still worked, yes. Because essentially what you're doing is, with the half diagonals in the base, you're doing a side-side-side triangle construction 6. That's really all it comes down to. Anyone happen to get this? It doesn't sound like, it doesn't make sense now. All right, let's take a look at a couple more of these. And I want you to do let's do number 10 together. Number 10 together. It's another parallelogram. But what are we given this time? Genesis?
An angle. Construct any parallelogram having given an angle, one side, and the altitude on that side.
You said given angle, given side, and altitude on that same side? All right. Before we draw any of these things, let's do a sketch. Let's draw a sketch first, so we kind of know, kind of like last time, we used the sketch to tell us how to draw the diagonals. We had one about the same length, we had one that was quite a bit longer. Let's start with our parallelogram, but you notice this time, no diagonals. So there's my parallelogram. Now I'm given an angle. There's only 2 kinds of angles you can have in a parallelogram class. You can either have acute, or you can have obtuse. If they were right, it's a rectangle, right? So I can either give myself acute angle, which would be these 2, or obtuse angle. Chris, let's go with acute angle. Okay, so let's draw an acute angle. And by the way, the fact that Chris picked acute means when I do my construction, I'm going to start at this vertex. Does that make sense? Okay. If you picked obtuse, I would choose to start at that vertex. But he went with acute, I'm going to put it there. All right, so there's my given angle. Now, technically, you could give yourself either side, but it does say the altitude on that side. And an altitude means perpendicular. So I don't know that I want to go putting perpendiculars across this way, because we never look at perpendiculars that way, right? Or altitudes that way. So I'm really inclined in making my, my side to make this baseline the side again, and my altitude coming down this way. Does that make sense? Now, compare the altitude to the side. Thoughts?
It looks equal.
Maybe equal to the
Length.
Yeah, to me it looks maybe a nudge shorter. Realize if the altitude is longer than the side, it's going to be a tall, skinny guy, right? If I make the altitude shorter, it's going to be a longer one, almost like the shape of Tennessee, you know? U.S. history people.
We have 2 trapezoids, right?
What?
Those are 2 trapezoids now, right?
Essentially, yes, you've made 2 trapezoids now. But if it's about the same length, it's going to take about this shape. So I'm thinking maybe a nudge smaller, but not too much smaller. So let's pick a side, and I don't know, you might want it to be fairly long, I don't know. But let's go and pick a side, and label this side, or you could label it base again. And then pick a line that's shorter, but not, you know, too terribly shorter, and call it altitude. Now, realize this, the altitude can go a lot of different places, can't it? Not in a triangle, but I could have put it any of these places in here, couldn't I? All right, let's start with the long line, yes. And again, because my altitude isn't going here, I'm going to pick my first endpoint just to be my starting point. Chris, thoughts?
Well, I think if it was me doing the first action, I would do would be cut the angle.
All right, you want to go ahead and copy the angle? I forgot to even mark that on the sketch. Yeah, let's go ahead and copy the angle and put it right there.
I did because I fell back because it was over.
All right, so make arc, measure across, measure across, connect los datos. Check. All right. Somebody else. Kendall, thoughts?
You could measure the base.
They didn't measure the base. Mark it off. Maybe that might have been the first thing you were inclined to do. Doesn't necessarily matter the order here. And this gives me a second dot that I know. All right, Genesis. Thoughts?
Are you gonna have to do measure the altitude?
Okay. And what do I do with it?
Put the polynomials on the baseline dot.
Like this one where?
On the one that you made when you measured it off.
This one here? I could, couldn't I? I mean, there's nothing that says I can't put my altitude right at the very end of the base, correct, class? However, Genesis, if I put it here, where am I measuring? Right? Because here you see a line for the altitude. I don't have a line here to mark off on.
On the angle.
Well, but the altitude isn't along the angle. The altitude's straight up and down. The altitude is... so what should I probably do before I measure the altitude? Let's make a perpendicular. Now, we can put it at this dot if you want to, and I see no reason not to, class. Agree? I mean, you have to put a dot somewhere to make your perpendicular. Why not use the dot you already got? So, yeah, I'm going to go ahead and make my perpendicular first, and then let's measure the altitude so we have a place to mark it off on. And I'm going to go and use white since I used white in my sketch there. That, and since this isn't actually a side of the parallelogram, I don't want it to be yellow like the other sides.
I have a question.
Yes?
So, what was the reason of doing that though? Like I see what you're saying, I see no reason, but I also see no reason to move it from where we had it in the sketch.
Well, because in the sketch, it was just in a random spot. I mean, we could have just picked a random place and put it there. Genesis had mentioned putting it here, so I went ahead and just moved it. But yeah, you could have picked any random point in the baseline and put your perpendicular.
So there's no difference really.
Yeah. And now, Genesis, now that we have this perpendicular, now let's go ahead and
Measure the altitude.
there we go. And now let's measure our altitude. And I know that's going to be, now this isn't necessarily, class, one of my vertices, but I would say that's a special point. All right, thoughts on what we could do now?
Well, you can't connect the dots because we don't know, like, for a fact that that's how long that angle needs to be.
Right, this line, well, yeah, and frankly, once we know this dot, I know this line, but there is another line through the dot, class. There's another side.
Oh,
There's
it's
a
equal to the base.
parallel, isn't there? So in other words, if I could just run a parallel across here, once it bumps this line, I would know this point. Does that make sense? So how do I put a parallel through here? Make another perpendicular, right? Because this is perpendicular, now make another perpendicular. And this is the method that Chris actually preferred when making parallels, was a double perpendicular. And that's the perfect thing to use here. Now, if your line is really, really short above, it's going to be a little harder. My compass can just make it, but yours, you know, you may want to extend your line. I can just get a couple of crisscrossing lines there.
Can we mark off the rest, like that once it's connected?
All right, so now I have a third vertex. And there are a bajillion ways to get the fourth vertex. All right, so let's see here. Ethan has been strangely silent on this one so far. Ethan, there's really a lot of ways we could go here. I have 3 of my 4 vertices. What's a way we might find said fourth vertex? Well, so far I've got these 3 dots are these 3 dots. And this is not a vertex, but it is a dot that I've got marked. But I'm missing this vertex right here. I've got 1, 2, 3, 4 ways I can think of to find it. 1, 2. Which angle? The acute angle?
Yes.
Ah, you see, class, if I were to have the line extended, which I do, this angle right here would run parallel, and it would hit somewhere around there, and we'd have our parallelogram. That's method number 1. That's not my preferred method, but it would work. All right? Anyone have another way we could finish it?
So we would measure the side on the
Method number 2, this would be my preferred method. Measure this side, which is equal to this side, and once you've got the measurement, mark it off. And you've got, that's the easiest way. There's a third way though. Before we do that, let's think of another way. You could measure this side and mark it off. Or the last way is a little bit more obscure. If you extended this, it's very similar to what Quentin said. You could copy the obtuse angle and still get that line going up. I think the easiest way, the best way probably though, is simply to measure the given side again. Oh, it's not as far over as I thought it was. And there's our fourth vertex. And that's what we construct instead of using our eyes. And when we connect the dots, we've got our parallelogram with a given altitude, given side, and given angle. Questions on this construction? Are you beginning to see how to think through these? I'm a huge fan of key points. They don't always have to be vertices. Vertices are the best points, right? Because that finishes the figure. But key points. Points of intersection of diagonals, points of intersection of altitudes, all kinds of stuff like that. I want you to look over across on the next page here, and I want to look at number 11. And we're going to construct a trapezoid. Now the book has a suggestion that is excellent for constructing trapezoids. The key with a trapezoid is 2 of the sides are parallel, 2 of the sides ain't parallel. Agreed? Which means these 2 parallel sides ain't equal. But I do know this. Imagine making this length marked off here. If you were to connect the dots, what shape would be formed right here, class? A parallelogram. And if you can think of, since we just did parallelograms, and by this point we should understand how to think through a parallelogram. If you can construct a parallelogram and a triangle, then you can make the trapezoid that way. Kind of like Chris happened to notice earlier, hey, you form two trapezoids by drawing that altitude. Breaking a figure down into other parts, especially, we know triangles inside and out, don't we? We know parallelograms inside and out. Trapezoids a little bit more, well then make it something that you know. And that's oftentimes a very helpful technique. We're going to work with other polygons later on in the year, 5, 6, 7-sided polygons. You know what we're always going to break them into? Triangles, because we know triangles. So similar idea here. Look at number 11. What are we going to construct in number 11, Jamie?
an isosceles trapezoid given the basis and an angle.
The basis and an angle, okay? Isosceles trapezoid. Now that's significant. Not just trapezoid, isosceles trapezoid.
Oh, so bases, like there's multiple bases.
Given, and you said bases?
Yeah.
So both of them, the short top one and the big long one, and an angle. All right, so let's start with the sketch before we draw the stuff, right? Isosceles trapezoid is going to have a short on top, long on bottom, right? What's going to be true about the legs, class? they're going to be equal because it's isosceles. What else is true because it's isosceles? That's special.
Isn't there something like the angles are going to be equal or something?
Yeah, the angles at either base are equal. So the two acute angles are going to be equal, and the two obtuse angles are going to be equal. So legs are equal, angles are equal. Now, this doesn't really help me, but also the diagonals would be equal. Rectangles and isosceles trapezoids, though I'm not given any diagonals, so I don't know that that necessarily helps. The bases are certainly not equal, but the bases are parallel.
Wait, no name line.
No, this median would actually join the midpoint, it's not no name line. But yeah, I don't have legs, so finding the median would be hard. But the median would be parallel, and half the sum of the bases.
Yeah,
all
I
kinds
was
of
just
stuff
thinking
like
if
that.
we could find that, then any line cut off by a transversal between parallels is equal or something. It was really far back.
Any line.
Or any angle or something cut by a transversal between parallels is equal. It was something like that.
Yeah, I'm not quite sure what you're trying to think of there. So we're given the bases. Now, that means we need to draw our lines, so one's shorter, one's longer. So let's give yourself bases, and let's draw a longer line and a shorter line. And B sub L and B sub U for base lower and base upper. All right, or you do B1 and B2 and just know those short ones goes on top. Now, technically, by the way, if you were to invert it, it'd still be a trapezoid, right? So technically, you put the big one on top, I guess. And then an angle. Now, there's 4 to choose from. Well, really, there's 2 to choose from, right? These 2 or these 2. Do we want to give ourselves an obtuse top angle or an acute bottom angle? What are we thinking here, Chris?
Acute.
You're going with acute, okay? So let's go with an acute lower angle. So we're going to be given this angle, and we know that means we're also given this one. We're given this base, and we're given that base. All right, so go and make yourself an acute angle.
Big long one?
All right, big long one. And again, I'm not making any perpendiculars here, so at least not on an end point. I guess I could make perpendiculars, I suppose. So let's just make the end point our starting point. And let's see here, Audrey, what first? We could, but Audrey, when we copy the angle, we're going to want to copy it how many times? Twice. Once here at this point, and once at, oh, there's not another point, right? So again, because I'm lazy, if I take your suggestion, I'm copying an angle, I'm marking off, and then I'm copying it all over again a second time, it's easier to copy it twice right at the same time. So let's start with the baseline. Yeah, let's start with that longer base or lower base, B sub L for the lower base. Again, only because I'm lazy. And lazy people like me overthink everything. Like, wait, if I do it this way, then it's going to make it harder, and I don't want to do it harder. So, all right, but it would not have been wrong, Audrey, to your point. Then, Audrey, we will copy the angle. But when we come here and we make our arc through both sides, don't just come over here and make one arc. Go to the other point and make that same arc going the opposite way. And we measure across both of them. Across the first and across the second. Across the first and across the second. Now what's hard is if the arcs are overlapping each other. Right? Then you have to think, okay, we're staying on the correct arc here so we get the correct angle. And when we connect the dots, and there we go. We've got our isosceles triangle. Any questions?
It's not a triangle, that's what we're supposed to be doing, a trapezoid.
Oh man, we're supposed to be doing a trapezoid? What? How did I do an isosceles triangle? Well, because obviously, if you make the sides longer, they're going to intersect and make a triangle, right? They're going toward each other. It just means somewhere along here, somewhere along there, is where my my other base is supposed to go, right? But where? Oh, I'm good. If I knew my altitude, I'm putting a perpendicular to another perpendicular across the top of the altitude. I've got it, but I don't know the altitude. I just know how big the other base is.
You know, I have an idea. I don't know 100% if it'll work. If
Well, we do have an idea that'll already work that we talked about before we even started.
Cutting it into what we know.
Yeah. Break it into a triangle and a parallelogram. Do you remember how I said we would make it into a parallelogram?
Would a triangle and a triangle work better since we know more about triangles?
Can you make it? Well, if you knew a diagonal, yes. You could do triangle and triangle. We don't know a diagonal.
That's true.
But if I were to make, remember, a parallel across here, right? Then this piece would have to be how big?
You have the top.
The same size as the upper base, right? So realize if I were to mark that off, and then copy this angle now a third time, I'd have corresponding equal angles, parallel lines. Does that make sense?
Yeah, but we just don't have.
And wherever this line goes up and hits this line that's already there, that's a top vertex. Does that make sense? So we know two vertices. We know the bottom two. We could get this guy by making a parallel. Make sense? So let's go ahead and well, first
Copy your first base.
copy the upper
Or the
base,
short base.
right? The short base, and mark it off
On your bottom base.
on the bottom base, just like shown in the sketch. So here is my upper base, B sub u. This is not a vertex, but it is now a key point. Make sense? What did we need to do once we got that key point? Make a parallel. How do we make parallels?
Just
Equal angles. Parallel lines always give equal angles, and if you want parallels, you need equal angles. How do we make equal angle? Copy the angle, right? Now notice we're going to copy it to the right side of the dot. So I'm going to copy it over here. This is my dot. It's going to copy over here. So open your compass a different amount than you used last time. Don't try to match the same one. Just make it easier, and so just pick some different amount. And make that arc. Measure across, I had it. Measure across the arc. And again, this line technically is not part of my trapezoid. It's just an extra line. It's more of an auxiliary line, one might say. But remember, wherever this parallel, notice running parallel to the other leg, wherever this parallel meets up with this side, that's that top vertex. Well, there it is. Make sense? Now what?
well, I'm gonna.
We got 1, 2,
We have the
three ways of
we have
finishing.
the obtuse angle now. We have all the angles now, because when you made that parallel, you got the acute angle, so the other one has to be the obtuse.
Oh, you're saying that this angle
Yes.
is obtuse. That's correct.
It's also the angle that we didn't have already.
Ah, you're saying that's that angle up here?
Yes.
It is that angle up there.
So.
But I don't have that but I have this vertex. There's 4 ways to finish. I stand corrected. You could copy this angle right here. So if I copied this angle right here, I get that line, right? That's one way. That's not the easiest way, but it is a way. Good thinking. All right, anyone else got another way we could finish this?
Make a perpendicular one.
Make a perpendicular line.
From point to side.
From this point, make a perpendicular down.
No,
Oh, to the side. I see.
to side.
That's not a perpendicular, that'd be a
Oh yeah, there's
Parallel.
parallel. Okay, I can make a parallel. Oh, there's another way. Okay, I could copy this angle above the point. When I connect over, I'd get a parallel. I could do that. Okay, that's also not the easiest way, but that would work. All right, someone else got another way.
Why are we so good at finding the hard ways?
So, could we do something with the upper?
You're saying if I were to measure the upper base again,
Could we put it on the point we just got with the triangle?
right up here,
Yes.
and then
And make an arc?
and wherever it intersects over here, you just connect the dots across? I think that's a great way to do it. Let's do it that way. And that will give us our trapezoid. Another way we could have done it that would have been just as easy. We know that the legs are what class?
Equal.
And once we knew these two dots, we knew one leg, didn't we?
Correct.
Measure the leg here, and then mark it off right here.
Is that the way you were thinking?
That was the way I was thinking, but the upper base is basically the same step, right? And except it relies on something that was already given, which technically makes it better than the other. My way is just easier, but this way was better. Questions on this?
So basically, me and Quinn, if we were doing this by ourselves, like
You would have gotten it. You'd have gotten it.
we would have taken a lot longer.
It's okay. It doesn't matter. You'd have gotten it. That's the main thing. Is get it right. All right. You're going to have 2 of these to practice over the weekend, and then Monday we're going to take a quiz. We've done a lot of these. The quiz is going to have, I believe, 3 constructions. I believe at least 2 of them you've seen before. There may be one you haven't, but should be able to think through. We will, of course, go over the homework before taking that quiz. We're also looking ahead toward a test coming up on Wednesday, which will have memorized constructions, unmemorized constructions, simple loci, compound loci. So 4 topics on the test. I believe there's 4 pages, 1 page per topic if I'm not mistaken. But it's been a year since I last saw the test. Homework is to do page 182, pages 182, exercise 3.34, numbers 7 and 12. Pages 182, exercise 3.34, numbers 7 and 12. Number 7 is a rhombus, and number 12 is an isosceles trapezoid. And we'll take a look at both of those on Monday in our next lesson. Have a wonderful rest of your day and a wonderful weekend, and I'll see you back next time.